Hi everyone, welcome to another episode of Coding Bytes. I'm Jovin, an educator at Coding Lab. Have you ever wondered how apps can detect faces and even guess a person's age, gender, or emotion? Today, we are going to explore how to perform face detection and analyze attributes such as age, emotion, and gender using Python. Let's dive right in. Here is a preview of what we will achieve by the end of this tutorial. We will detect faces in an image and analyze their age, gender, and emotion. You can see the detected faces along with their predicted attributes. Now, let's start coding. For today's project, we'll be using Jupyter Notebook on Google Colab. Google Colab is a free online platform provided by Google that allows us to create and run Jupyter Notebooks in the cloud. You can access Google Colab by following the link in the video description below. Simply sign in with your Google account or create one if you don't have it yet. It is a convenient way to get started with Python without needing any local setup. We will be using the DeepFace library for face detection and analysis along with Matplotlib for displaying images. DeepFace is a lightweight yet powerful face recognition framework for Python that includes pre-trained models for face detection and analysis. After signing into Google Colab, let's get started by creating a new notebook. Then let's give it a name. Before we can use the necessary libraries, we need to install them. In a new cell, type !pip install DeepFace. And then run the cell by clicking the play icon on the left side of the cell. This command will install the DeepFace library. Once installation is complete, we are ready to use the module in our Python program. Now, we need to import the necessary modules. Start by creating a new Python code cell by clicking the plus code button at the top left. In the new code cell, type from DeepFace, import DeepFace, import matplotlib.pyplot as plt. Then let's run. Google Colab comes with Matplotlib pre-installed, so we don't need to install it manually like we did with DeepFace. Remember to match the exact uppercase and lowercase letters as shown, since Python is case sensitive. Next, let's upload the images we want to analyze to this notebook. I'll be using 4 example images: fear, family, a town with no people, and woman. To do this, click on the files icon on the left, and then click Upload to Session Storage. Select the files that we want, and click Open. After uploading, the files will be in the same folder as our notebook. Now, we need to specify the path to the images we want to analyze in our notebook. Create a new cell, and use variables to define the file names of the files we just uploaded. For instance, let's use image1 path to represent the first file. And you can do the same for the rest. Image 2, image 3, image 4, and their corresponding file names. Remember to run the cell. With the prep work done, we are ready to dive into the main part of the program. Let's get started. With the image path defined, we can now use DeepFace to extract faces from the image. The extract faces function will return a list of dictionaries, each containing a detected face and its attributes. The function takes in the image file path as an input argument. We will use the variables we defined earlier for this. Let's create a new code cell. Inside, type face1 equals DeepFace dot extract faces. Image1 path. We can do this for the rest of the images as well. Face 2, 3, 4. Image 2, 3, 4. Go ahead and run the cell. Note that if an image does not contain any faces, DeepFace will return an error. Face could not be detected. For example, in our third image, the town photo, there are no people inside. We encounter this issue. To handle this, let's comment out that line and rerun the cell. Let's inspect the first detected face to understand what kind of data DeepFace provides. We will print out the details of the first face by typing the variable name, face1, and then running the cell. Each detected face is represented as an array, as seen here. We can access this array to manipulate or display the face image under face. Let's print the face array for the first detected face. Using matplotlib, we can display the face image given the face array. This helps us visualize the detected face from the array data. To do this, we use the imshow function and supply our face array. plt.imshow face1 0 face. We can also use the axis function to hide our graph axis for a cleaner view. plt.axis off. Finally, we use the show function to display the result. If there are multiple faces detected, such as in our family photo, we can display all of them side by side using subplots. This way, we can see all detected faces at once. We start by using the figure function, plt.figure, to create a figure with a width of 10 inches and height of 5 inches. Next, we will use a for loop to go through each detected face. Let's start with for I, face, enumerate, face 4. The enumerate function provides us with both an index and a face object, allowing us to work with both in our loop. Since each tuple contains two elements, an index and the face, we will use two variables in our for loop. Inside our code block, we can use subplot to specify the position of each face image in the figure. In the arguments, we put 1 to indicate that we want a single row, with the number of columns equals to the length, face 4, which is the number of detected faces. Then I plus 1 is our current subplot position. Next, we will then use the imshow function to display each face. As with what we have done previously, we can use the axis function and set it to off, resulting in a cleaner view of the face images. Finally, outside of our loop, let's do plt.show to display the complete figure with all subplots. This cell will generate a single figure with each detected face displayed side by side in its own subplot, giving us a clear view of all detected faces at once. DeepFace not only detects faces but also analyzes attributes such as age, gender, and emotion. Let's perform this analysis on our images using the analyze function. We start with variable face1 analysis equals DeepFace dot analyze. Similar to our extract faces function, we need the file path. Let's put in image1 path that we defined earlier. And do this for the rest as well. Face 2 and face 4. And then let's click run. Now, let's see what facial attributes were detected by the model for face 2. To do that, type in face 2 analysis and click run. Now, let's learn how to access specific attributes, such as emotion from the analysis. We can print out the detected emotion by accessing the dominant emotion key in the list of dictionaries. We will start with the variable face2 analysis declared in the previous cell. We will then access the first index in the list as it is the first and only face in the image. Then we will use another square bracket to access the dominant emotion P to find the emotion detected. By following this method, you can access other attributes such as age and gender using their respective keys. To make the results more readable, we will print the analysis for the detected phase, showing the predicted attributes, age, gender, and emotion. We can use print statements to achieve this. The print statement takes in multiple arguments separated by commas to construct a sentence using the values we extracted from the phase 2 analysis dictionary. Let's start with the print keyword, then the detected phase. In, which is a static string that introduces the information, followed by image2 path, giving context to which image the analysis refers, comma is A, which is to connect the image path with the detected attributes, followed by our age value extracted from the analysis. Phase 2 analysis, 0, age, comma, years old, comma, the dominant gender detected. Phase 2 analysis, 0, dominant gender, comma, another string whom appears to be, comma, then our dominant emotion detected. Phase 2 analysis, 0, dominant emotion. And then run. This format makes the result easy to understand and provides a complete sentence describing the analysis results. It is important to note that machine learning models, including DeepFace, work on probabilities and predictions. This means that results may not always be 100% accurate. For instance, a model might predict an age that is slightly off or a gender that doesn't match the real-life identity. Understanding these limitations is crucial. Machine learning is not perfect, and recognizing the possibility of errors helps us to use these tools more effectively. Always be aware of the likelihood of any error in machine learning results. Finally, let's combine the phase images with their corresponding analysis. We will display each phase with its predicted attributes as titles. To do this, we can reuse the for loop code we wrote earlier. Just go above to copy and paste it below. To add in the predicted attributes, we will use the title function. Similar to our print statement, we will be using string concatenation to combine the attributes into a single string. In between the image show and axis function, let's type in plt.title. We will concatenate the age, gender, and emotion attributes. The variable I will represent the current phase that we are accessing. Let's start with age. Phase 4, analysis, I, age. Then gender. And emotion. Remember to use string to convert your age to a string, as string concatenation only works when combining strings. Finally, run the cell. And it will show all faces with their corresponding attributes above it. With that, we have come to the end of this tutorial. I hope you found it informative and exciting. If you enjoyed this video, please give it a like and subscribe to our channel for more Coding Bytes content. Remember, improving the accuracy of these models can be a fascinating challenge. I encourage you to explore ways to enhance model performance, whether by using DeepFace or by building new models with other libraries. There's always room for improvement and innovation in machine learning. Thank you for watching, and I'll see you next time. Bye.